Hey, this is Mark Smith, and I'm excited that you are here for the replay of Cracking the Code of Direct Measurement and Remote Management, a webinar replay sponsored by BR&E and Engineering and CleanConnect.ai. Now, you're in the right place if you came here to discover how we use ProMax 6 data exchange feature plus CleanConnect's real-time AI monitoring solution to transform existing data into source-level emissions measurement that meets EPA regulations. The three things regulators are looking for to get permit approval under the new EPA and state regulations: how to future-proof upstream sites to enable remote monitoring and management and eliminate unnecessary callouts, how to design in direct measurement systems that will minimize future EPA methane taxes, and the 7 AI-enabled features your clients will gladly pay you more money to design into their sites. My name is Mark Smith, and I'm the co-founder of CleanConnect.ai, host of Digital Roughnecks, a video podcast for the oil and gas industry, founder of Windows NT Magazine, which went to IT professionals in 160 countries, and the creator of the EPA cheat sheet. We are a hardware-enabled SaaS company. We're the first government-approved continuous OGI source-level leak detection system, the first government-approved source-level GHG intensity verification protocol, 2022 Darcy Partners Top Innovators in the sustainability category, and 2023 winners of the Oil and Gas Clean Tech Challenge. Now I want to introduce you my business partner, David Conley.
Yeah, super excited to be here, and I can talk a little bit about what problems those looked like. I wish we could take credit for everything that we've built, but unfortunately we can't. I'm just kidding, not unfortunately, but we can't. Our customers have told us what to build, and we build it, right? And what that looks like today is the Autonomous 365 suite. So we're a computer vision company that leverages cameras to do remote inspections, management, monitoring, all the things. So really where we got legs was around the autonomous LDAR compliance piece of things. You leveraging OGI cameras and methane only cameras to detect fugitive emissions, and then what to do with that data. We do lots of things: gas leak detection, quantification, security, hard hat recognition, explosion detection, compressor run status, non-invasive tank level monitoring, which is actually the first thing we built, loadout observation, pumper truck monitoring, and we even have gotten into the blockchain to take all of that data, and that's what we'll talk about today. But take all of the data and make sense of it and make it and validate it. So lots to cover on the product side of things, but I think we'll get into that. Get into that as we go. So,
Justin, welcome here. We're super excited to be partnering up with BR&E or ProMax on our journey to help solve our customers' problems. So, Justin, why don't you introduce yourself?
Yeah, so I'm on the ProMax side of things. So with BR&E and Engineering, our company's been around for almost 50 years now. And I see so many familiar names over here on the list. So lots of y'all are here. You're probably very well familiar with ProMax, but we are a process simulator that takes a first principles approach to modeling and understanding what your emissions are. And we released a new feature inside of ProMax, which will connect your model with your database as well. So you can automatically bring in data into your models. And we're going to get more into how CleanConnect has used that and how we worked with them on that too. And how you could actually do that too. So super excited to be here. And I'm glad that to see so many familiar names out there.
Yep. So let's talk about the why we got into this stuff. Well, our clients are facing numerous new regulations, which now require measurement. So EPA Subpart W, it impacts almost all the operators. now requires source level measurement informed inventory. That was introduced in the Inflation Reduction Act, which also included a methane waste fee if you exceed certain baselines. CDPHE, Colorado, also required a source level measurement informed inventory, and there's a potential GHG fee as well. It requires a source level measurement informed inventory. SEC has now said, hey, we want some climate risk reporting that impacts publicly traded companies over $1 billion. Talking about scope 1 and 2 emissions. Potentially there's fines if you don't do it. EU has something similar called the CSRD. It's for operators, with more than 500 employees, scope 1 and 2 emissions. The UN, a lot of our clients have signed up for OGMP 2.0 level 4 and 5. It's voluntary. But that also requires, to hit level 4, a source level measurement informed inventory. With level 5 is a site level reconciliation. If you don't do it or you miss it, because you have 3 years to get it, if you don't, you could lose it for a year, and that's reputational risk. But this one, the follow-on, MMRV, which I'll get into, impacts anybody who wants to sell into the LNG supply chain. And 20 countries have agreed to use this particular framework as the basis for trading LNG. And EU has said, hey, if you can't meet this framework or get below a threshold, there's potential carbon border tax. And we have clients also who need to prove their emissions as part of their, either a sustainably linked loan, or it's they have ESG investors, or for numerous reasons, even insurance companies requiring proof of emissions. So lots of reasons why you need to measure. EPA subpart W, the timeline. So as EPA cheat sheet, I've been covering this stuff a lot, so I'm going to go over this real briefly, but basically subpart W, the drafts were hit in 2023. Quad B and C finalized, and that is done now. About mid-2024, the states have to send in their SIP plans, or state implementation plans, to the EPA, and then EP subpart W will be finalized, and the new super emitter, which is another reason, is going to hit, is super emitter regulation, which basically satellites flying over the continental US and eventually I'll show you the world, looking for 100 kilogram per hour or more leaks. January 2025, everybody should be doing source level measurement, okay, to do a source level. And then March 2026, you turn in that 2025 data and you could have a methane fee based on that data. Upstream, if you exceed your baseline of 0.2% methane intensity, midstream is 0.11, downstream 0.05. And January 2027, when those states are supposed to implement their plans, which are equal to or more strict than Quad B and C and subpart W. Here's something in a global look of it. So as I mentioned, a lot of these things are coming in 2023, the drafts. 2025, empirical measurement starts for US, EU CSRD. The methane tax kicks in, EU reporting is due, and this global super emitter thing is happening. So it's happening in the US, could start as soon as next year. It could start worldwide in 2026. And then carbon border tax.
The worldwide, is that still part of the EPA regs, or is that a different?
No. So what's happened is, as part of this whole this MMRV, these 20 countries said, hey, we're going to do the same thing. Gotcha. So basically, if you're a satellite company and you qualify, you can not only win a US contract, but a worldwide contract. Okay. So when we look at this, as engineers, software engineers trying to figure out, okay, how do we solve this for our clients? Is this 5 different projects or one project that has 5 outcomes? So we look at the puzzle of, the EPA stuff, subpart W, Quad ABC, MMRV, OGMP, Colorado's regs. And Colorado is probably the toughest of all of these, to be honest. So, and that's where we got our government approval, and then financial and SEC. So we look at the whole puzzle. Subpart W introduced this idea of 5 new measurement methods. Okay, so it's basically the lower the number, the lower the uncertainty, whereas the higher uncertainty. So direct measurement is method 1. So if like at a continuous flow meter, or like our solution, continuous OGI with quantification. And how you can determine if you're there is if you can measure a duration, size, source of an emission event. Okay. Then they introduced this idea of engineering calculations, and ProMax is actually mentioned as subpart W 26 times. And it's saying, hey, ProMax version 5 or higher is mentioned and as an approved engineering calculations. So when you combine direct measurement with a calculation, you can get method 2. Okay, so like we would combine it in different ways to get this, and I'll show you an example. And then if you'd like, use ProMax by itself for a site-specific simulation. And then level 4 is where you're using LDAR, and that is so you can reduce the number of days in a duration of an estimated leak. And then number 5, that's basically emission factors, what we have today. So an example of why measurement is important is this. So let's say you had a cold venting, unlit flare. All right, so direct measurement, let's say our OGI would go around, catch it. We'd see the start, the stop times, and we would send an alert. And let's say that our client was able to, reboot, separate, or do whatever, get that thing back, and 50 kilograms were released. In the Inflation Reduction Act has the 3rd-year tax at $1,500 a ton of methane, be about $75, and it's below the 100 kilogram per hour threshold of a superemitter, so it's not one. But let's say that you just had a thermocouple and temperature started dropping. SCADA sent you an alert, and you rebooted it, but 200 kilograms got away, $330, superemitter, yep. Okay, it is. But now you get down here to just calculating by itself with no direct measurement. What the subpart W is, it forces you to use some of these defaults like 182 days or the default emission factors. Okay, and you can see it could add up quite a bit if you were to use tax. Now, again, this isn't supposed to be tax advice or anything like that. We're just trying to show you what these different measurement methods get, okay? All the way as you fall all the way down. Now, LDAR, for example, you could make a claim, subpart W does have something to say, okay, but I did a regulatory LDAR 90 days ago. Can I use 90-day default instead of 182? They seem to allow that to happen. And then factor 5 is just standard emission factors. Okay, so you can see why the implication of direct measurement, why you're really going to want more of that. Okay, so monitor, measure, monetize. Our first use case is autonomous inspections. It's basically taking what most of you do. Okay, guys going out and doing manual LDAR and replacing with autonomous LDAR. Basically, in our scenario, typically we have one camera on a site. It can cover, I don't know, David, 99% of the upstream sites are been covered by a single OGI camera mounted on a pole along with some other cameras. That's about right?
Yeah.
Yep.
The exact numbers or the certification allows for up to 100 meters at 5 kilograms or less, or 5 kilogram kind of MDL. Our recent testing gets us closer to 280 meters, 300 meters, depending on the size of the leak. So in terms of like a super emitter, 5 kilograms an hour is much different than 100 kilograms an hour. So yeah, we got quite a bit of range for sure.
Yeah. Now, one of the things your team has built, David, is this brand new digital twin thing. And, at first it was just built for us so we could not guess where to put a tower, but literally like simulate on site. So when their installers are there, they can tell precisely where to put for the best viewing angle.
Sure.
And then in addition, when you get down, we allow tour stops, but within it, so if you say these 4 tanks in a frame, you could name it, set the pan, tilt, zoom, whatnot. But then also you're able to draw a polygon around a specific object. So that way, when we see an emission event on that tank, you can then have measure the emissions for that specific tank. But it allows us to do some other things. So here's tanks overpressuring 200 feet away. As you can see the leak, you can see what it is. You see it's being measured. Here's cold venting at 4 a.m., 300 feet away. So yes, we work day or night, 24/7. And here's one that really drives some technologies crazy, is a load out event, right? A truck shows up, doesn't connect correctly, starts leaking, and then it drives away. Okay. So after how many
drives away, but you still have to figure out what the source was.
Right. Yes. Yeah. It's an emission event that could literally, if it was leaking that much, could create a super emitter event. You get dinged, and yeah, at least you could have the proof with our stuff. You caught it. You're showing us, say, yeah, it wasn't us. It was a third party truck. Now they may blame you anyway, but okay. So how many videos do we have? I mean, we've been doing this continuous on so many sites where we've got well over 1 million videos, right?
Sure. Yeah. Right now our model's trained on 30 million data samples or so.
So the things that we see we see cold venting as a big, tanks overpressuring, loadouts like you saw, and other. That's why we showed you those 3 examples, because those 3 most common things we see. So not only can we monitor them, we measure them, we can report on them, but you're going to see later in this presentation how we're actually trying to prevent those things, even prevent super emitters. Okay, this is what we had to do to get our alt-aim. Okay, so which is the alternative approved instrument monitoring method from Colorado. We had approved source level detection, then blind testing, and we'll talk more. David can talk more about that, and then LDAR equivalency. So we had to prove that our autonomous LDAR was equivalent to monthly manual LDAR. Alternative work practice. We had 2 operators endorse our application, and then we got EPA Region 8 approval. And it came with a workflow. So the big idea here is to have an increased cycle speed. So you have AI detection, even AI assisted diagnostics, and then a built-in repair flow system. And then once you say it's repaired, the camera will go around and automatically verify that, and then put all of that bottoms up measured inventory into a database so you can report on it. And then of course, all this data is being used to retrain the model to get it better and better continuously. This is our alt-aim approval letter. So what it means is that if you use CleanConnect, it replaces the need for regulatory monthly LDAR, regulatory AVO, regulatory tank emission monitoring. And for our clients, that eliminates 92% of the regulatory scheduled callouts. Now, what's new in the brand new Quado BC that just dropped, it's very similar to the alt-aim, okay? They added a few innovations, I think. Proven spatial resolution. So when alternative technologies apply, then they have to have a proven spatial resolution. So in our case, we're a component level. So we can see within 5 meters of a source. Area level is 2 meters from a source, and anything above that is site level. Same blind testing protocol. Equivalency, you prove against, in this case, for EPA, it'd be quarterly LDAR. Alternative work practice. And then they added the commercial availability. They will not approve anything that isn't, it has to be available to the public to be sold, leased, or licensed, okay? And then, of course, EPA approval gets you countrywide approval. They have a portal, the timestamps, and then if they don't refuse it or whatever, within 270 days of receipt, you're going to get approval or disapproval. Now, where the spatial resolution really comes in on the regulations is this. So screening technologies, that's anything, a technology that's cannot see, less than 2 meters from a source, or it's greater than 2 meters. So fence line monitors, planes, satellites, open path lasers. Alerts require the operator to use an inspection technology. So with these continuous things like fence line and open path, every 7 days, if it exceeds the baseline, which is set in the first 30 days of operation of the particular technology, then you're required to send an inspection technology. Inspection technologies are defined as a spatial resolution of component level. So method 21, periodic handheld, or like our solution, which is continuous OGI. And anyway, David, you could talk about this testing that we did for blind testing.
Sure. Yeah, I actually have a question in the queue that I can actually answer while I talk through this.
Oh, okay.
Someone asked, what are the limitations of autonomous monitoring? For example, OGI has wind and temperature limitations. True, right? That's and whenever we go back and we talk about equivalency, that's the key, right? Is what is equivalent versus a monthly LDAR inspection. In Colorado, it's monthly. In other states, it's less frequent. So whenever the temperature and the wind changes, you're going to see something, right? So depending on the temporary conditions, that doesn't disprove equivalency, if that makes sense, in the modeling. So whenever we did our equivalency testing and our blind testing, controlled release blind testing, so we're measuring what's coming out of a meter, and we're seeing if we detect it or not. And these are some of the results. So you're at out 2 kilograms an hour at 120 meters, right? And as long as we're under 5 kilograms an hour, we're equivalent. So that's kind of the way that it works. So yes, you're right. There are conditions that are less conducive to detections, but how long do those conditions last, right? And so and overall, is it going to be more frequent than every 6 months you're running an LDAR inspection, right? And so that's kind of the lens that you kind of back that up against, if that makes sense. So I hope I answered that question, but also this is going through kind of the line testing results. 98% true positive rate at 120 meters is the latest achieved. Again, we've done another set of testing that got that up to 240 meters to 280 meters, I believe. One of those two numbers. So yeah, I mean, we're constantly improving, and that's the key, and that's what AI enables us to do, is constantly improve those models over time. So.
And we did all these in our production facility, the blind testing, and all the results were reviewed by CDPHE, the Colorado regulators. And then we also did, in that same thing, using the data to do quantification. You talk to this slide a little bit.
Sure. Yeah. As part of that, with that controlled release data that we have, now we have ground truth, right? We have ground truth data that says, okay, truthfully, this is how much is leaking at this flow rate. And so we wanted to back that and put that against, how accurate is the quantification coming out of the AI model, just without any additional information, which we've tightened this with the ProMax, right? And so that's the magic, right? It is, we have these raw data outputs coming from the OGI plus the model simulations, and that's a little bit of the magic we'll talk about, is cracking the code. But this is raw data. 78% accuracy with an 8% outlier rate, and that's tested against 2 kilograms an hour leaks. So that's just what the data look like. It's just kind of raw data. But,
This, we want to give a shout out actually to Zach. He actually gave us this quote, but more importantly, he was really there from the beginning with us, helping as an early adopter, helping us steer this particular product. So we like to say that our product was co-created with an operator in mind. So, okay, next step, measure. So one thing that's important, especially for our clients that do OGMP, is this idea that they have these 5 levels. I won't even talk about level 1 and 2. Level 3 is called generic emission source level. This is equivalent to today's emissions inventory, which is emission factors. So level 4 is specific source level measurement inventory. That's first, and then you reconcile at the site level. So that's one of the things we'll be showing you how we do that. Now, building on top of OGMP level 4 and 5 is MMRV. Okay, and so these countries have got together and said, hey, we are agreeing on this measurement, monitoring, reporting, and verification protocol that's built on top of 2.0. So they're starting there and going from there and saying, hey, if we're going to be trading LNG, for example, between these or any other product, this is the protocol we're going to use to measure that methane in terms of carbon border taxes or whatever. Okay, this was, we built, as you saw, we did the computer vision stuff, but now we tap into the IoT devices, okay? And we add BR&E, the ProMax version 6 with the data exchange feature. All that runs through our AI model. And the original idea was we had a client, Triple Crown, that said, hey, can you create for me autonomous methane performance certificates using the S&P protocol? So we did that. And then Colorado came out with their source level measurement informed inventory, which was originally called Reg 22 or Regulation 22. So we were approved, we're built into their regulation in the framework, approved 0. It's the name of our system to do that. But in addition, as I said, we started looking at the puzzle piece and saying, well, wait, if we can grab computer vision, measure leaks, look at the IoT devices, and run that through ProMax, what all can we do? Can we help produce some of these other reports as well? So yeah, this section is autonomous measurement using ProMax plus CleanConnect to automate emissions tracking with process simulation. So Justin, why don't you take it from here?
Yeah, all right. Well, thank you. So up to this point, you've heard a lot of different regulations coming from the EPA, from the EU, MMRV, and then also there's the SEC as well, the Security and Exchange Commission. That's another piece in all of this as well. And that's where we're looking at these pieces as well. We have scope 1 and we have scope 2 and we have scope 3. They're all being litigated in courts right now.
Yeah.
But it looks like scope 1 and 2 are probably going to get through. Scope 1 is going to be looking at your more site-specific GHG emissions, and the scope 1 and scope 2 are only looking at the GHG emissions. But that's going to be everything that's happening on site. And then we have scope 2, which is a little bit more difficult to follow, but still you could calculate these. And that's going to be coming, that's the electricity that you buy that's coming across the fence. And you're going to be able to need to track those emissions as well and include that in your SEC regulatory reporting as well. All right, and then we have scope 3, and scope 3, we just have that listed down there as insanity. That one is basically all the other emissions that could possibly ever happen that you are in any way, shape, or form connected to. I mean, that could be anything like goods that you purchase that you're going to use on site. That could be your employees commuting to the site, the value chain of your products. You may not even know how your products are going to be used, but you're going to have to be able to report the emissions that come from how they're used. So that's why we just kind of put that there under that's a little bit more outside of reality, is what we see.
That's a scientific term, insanity, right?
That's right.
There's the definition.
Yeah.
So then basically the reason it matters that the SEC is getting involved is because there's one really important document that your board of directors are required to submit to the SEC. These are for publicly traded companies, and they're going to need to submit their Form 10K. And now this is an important document because if you are found lying or hiding things along those lines here, you can actually be found criminally responsible for it. So it's going to be something. I'm not a lawyer here, but that sounds pretty important to get right. And so that's going to bring in a whole bunch of different people to calculate these emissions, and that the board of directors are going to need to be working within the company in order to find out what those emissions are. But when we're looking at all of this, there are several different methods of calculating these. And so looking at those top three there are your emissions factors. And that's pretty much old news these days. The emissions factors are the quick and dirty way to make these types of calculations. It looks like these agencies are moving further and further away from recommending those emissions factors. But then we have the company specific data at the bottom, and that's actually where we plug in both CleanConnect and ProMax, which is why it's making it quite reasonable for us to be working together on things like this. And so a company's specific data could be things like using direct measurements like flow meters and cameras and LDARs, things like that. There's emissions software that you could use as well. Those three that come under the emissions software, those use more of a like correlation type calculations, which are more so on the emission factor side of things, but not quite emission factor because it brings in more of your company specific data. But then we have process simulation down there at the bottom, and that's the one that is going to be fully customizable to your site. And the reason I say that is because that one actually takes into account the first principles approach to calculating these emissions. It uses a physics-based method of calculating emissions, so it's actually not using factors at all anymore in this. And now you're actually getting real defensible, realistic results that are actually backed up by the science, not just by a bureaucrat coming up with a factor.
Right, and just to comment on that, I mean that right there was kind of the aha moment for me. Right, we were sitting down, working through mass balance, and one of my, chemical engineer we're working with, she said, well, I can see that source. Can you tell me what pressure and orifice size and temperature is in that line? And I can tell you how much is leaking. And that was it, right? It was wait, the visual piece of it mixed with the thermodynamic modeling and the physics of ProMax, and now I can give you a duration, right? And now all of a sudden you have a very interesting case of measurement, right? A very defensible measurement right there, so that was it. I mean, that was cracking the code from my perspective.
Excellent. Yeah, that's a good way to put it, because ProMax will not let you break the laws of thermodynamics.
Right.
And so that's kind of a neat thing about it, is a good sanity check of what you're actually calculating. Yeah. Yep. Good point. So then let's kind of look at what we have that the operators are looking at. So they have a facility, and they connect that facility up through instrumentation with a SCADA system, which will basically take the data that those instruments report from the facility and organize it and put it in some type of format, which will then go over into your historian. And so all of this is currently automated. So typically, when you install the instrument, you create a SCADA system, and then you attach that with a database. Now what we're proposing is you take that information from that ops historian and you build your model from it. And this has been done for a little while, but it's all been done by hand. So these engineers or these emissions consultants, these air consultants will go find the data. They'll have to rummage through lots and lots and lots of information, find the pieces that are important, record that somehow, probably copy and paste it into Microsoft Excel, and then go into the ProMax model and hand put it all in there. All right. Then after they do the model and they make those calculations, after that, they're going to be sending that over into a database or some type of reporting method as well. If you'll go to the next slide here, you'll see that you have your emissions historian, where you'll start storing that information. Well, a lot of times that historian is really just a Excel document. And then they take that information from the historian and then they start feeding it to all these other different places. So they'll copy and paste from Excel into an emissions inventory. They'll copy and paste from that. Looks like probably going to go into their 10K here coming up pretty soon. And then they'll copy and paste it from the historian and send it over to make operational decisions, if they even do that at all, because a lot of times the air folks and the engineers are not actually making decisions together, or the information from one isn't necessarily influencing the information to the other. So if we look more closely at this, at the ops historian to the model to the emissions historian part of this, this is where we see a lot of room for improvement, because there's so much time here that's taken up with this. So this data is manually taken from the ops historian to the model, and then manually taken from that and put into the emissions historian. Well, if you have a large number of facilities to maintain, which almost every producer does, that can take a bunch of time. And it's a lot of repetitive calculations. All these engineers or consultants will have to open it up every month, relearn it a bit, and then do it all over again, over and over and over again, or do it once a year, and then they really have to relearn it over and over and over again if it's only once a year as well. So what we can do is speed it up. If we can remove the manual data entry and we can increase the frequency of calculations, then we're going to have it work a lot faster. So what we propose here is automating it, okay? And once we automate all these pieces of it, we will have less human error, and we're going to be using a physics-based model like in ProMax, and all of it is going to be completely transparent. It's going to be auditable. You'll be able to go back in time and see exactly what you did. You can even pull up the model that you used at whatever period in time that you did this. And everything is going to be completely reproducible, which will be a pretty neat thing to be able to do. And then you can scale it up. At this point, you scale this up, and you can have one model that can represent a whole bunch of facilities. We have one customer right now using one model to represent 800 different facilities. And it does it by bringing in company-specific data for each one of those cases, and then we'll go from site to site to site to site, and all the data will change from one site to the other, but it's still just one model that you'll have to maintain, which is really, really slick. So then you can use these three things here. The scale, you can scale it up, you can make it faster, and you can make it more accurate by automating all of this. So then when you look back at this system, you can see here, we can automate it going from the ops to the model. We can automate it going from the model to the historian. And then we can even push data back into the SCADA system again, if you want to, which you'll see on the next slide here. It will actually show you kind of that progression as well. Okay, so when you automate all of those pieces, in your work as an engineer or your work as the air professional on this one is basically setting up that initial model and then linking that initial model to whatever tags exist in the historian. And then you choose how often you want the model to run and for which facilities you want it to run. And then you let it rip. And it can run all year long. It can run so far we've had some of these models running for 2 years without even needing to restart or anything like that. We've even set these up in case if the computer shuts down. Let's say that your server crashes and then you boot everything back up after a weekend storm or something like that. Well, right when that computer boots back up again, the ProMax model will be running automatically right from the get-go. So then there's not really going to be much human intervention once you have these running, except whenever you build a new one, or whenever you make a change. Let's say you put a new piece of equipment in one of the facilities. And the humans at this point will be able to work on what's really important, which is the idea of reducing the emissions or focusing their attention to increasing production or increasing quality of production. You get to focus on the things that are a little bit more fun rather than the the tedious work of data entry and the tedious work of copying and pasting to data sheets. Because at the end of the day, that's really what I want to get across here is if we can eliminate a whole day's worth of copying and pasting from one spreadsheet to another, I think that's a win.
Yeah, absolutely.
Absolutely. So here's how we've done exactly what Justin just said, our exact setup. So we have our cameras, which you've seen. They connect to our edge device. We can even connect up with Cimarron's SiteLink 360 to get more data in real time. Go over to SCADA, MQTT or Modbus. It's in SCADA, and then we get a feed right out of SCADA, just like he showed, through our ProMax data integration, and then our CleanConnect platform. Okay,
Yeah,
so
what's a little bit unique, right? And is when the CleanConnect system's out there, we're monitoring a site, a leak pops. Now we have a way to say, okay, a leak is happening right now, and we'll go pull the simulation. So just like you'll set up the model, and at that facility, at this equipment group, we're going to pull the simulation. We're going to run that simulation during the duration of the model, or during the duration of the leak, and we're going to give you a measured inventory for that fugitive emission and non-fugitive as well, right? And that's what's really unique about this combination.
So the big idea here is that all operators are needing to move to some empirical data, and if they can't move, they face a bunch of fines. But by doing this, we can create a source level measurement inventory that can satisfy all of these different stakeholders, which is really important. We put this for Triple Crown because they're one of the first ones to do this with that methane performance certificate. And Civi, we're working with them on all their sites to get all this real-time measurement going as well. So how do we monetize that? Well, here's what different clients are trying to do: minimize methane taxes, earn carbon credits, win ESG investors or keep them, comply with sustainably linked loans, earn certified gas premiums. So we have all these different scenarios. And one in particular that's coming up because the growth of LNG is about 25% compounded. The problem is that the countries didn't agree on a methane intensity measurement, and now with MMRV they are. And so with this, now we can actually create data and record emissions and actually capture that into the blockchain and actually create an NFTs for upstream, midstream, LNG plants, the ship. So when they take that over to Germany to a floating regasification plant and they say, hey, can you prove your methane intensity across the supply chain? The answer is yes. Great. Come on in without paying the border tax. But if you can't prove it, pay the border tax. So there's another way to monetize this as well. So here's an example that we did where, it cracks open a leak, it starts to measure it. You can kind of see that as the pressure relieves in the tank, that the quantity starts to reduce. But again, in our system, we're tracking the beginning and the end of all that. We also do tank level monitoring. Okay, so we can use this data as well. And we're nearly accurate as guide away radar. There's actually a graph of how we compare against guide away radar. Okay. Now, what you could do with that is pretty interesting, because if you start using AI and computer vision, you can start to predict when tanks will overpressure. And then we work with our partner company, Cimarron, to actually control a VRU, and they have a smart VRU system called ArcFlex. So we can say, hey, we think this is going to overpressure, send a signal, release some of the pressure, send that off to burner and eliminate that problem, eliminating essentially that. Now, why that's important also in the next part is Quado BC also says, hey, even though you get an EP certification for a combustor that's 99.9% in perfect conditions, we're going to slide that down to 95% in field conditions. They do make an exception for air-assisted flares like Cimarron's DreamMax. They can actually claim a 98% combustion efficiency, which has direct measurement impact on subpart W. You'll have to go test these every 5 years, but the way the regs work, they say, hey, you need to be in continuous compliance with your combustion efficiency. DreamMax is another thing where you can see cold venting or over aeration, and so we work with these guys to do computer vision plus their DreamMax so that we can automatically adjust flares in real time. Okay, so anyway, they have this DreamMax thing that allows us to tap into it, and we'll call it a smart burner management type system. Okay, so again, we're not only trying to monitor and measure cold venting and tanks overpressuring, but we're actually working with vendors who can provide direct measurement, but also remote monitoring and management for these specific use cases of cold venting and tanks overpressuring. So David, why don't you talk about our brand new camera systems?
Yeah, this is super exciting for me. This is something we've worked on for the last 2 years. Around there, whenever we would put our solution in, and total cost of implementation was high, right? I mean, talking about OGI cameras, a lot of off-the-shelf compute, a lot of just off-the-shelf parts have been marked up 5-6 times before they actually get to the end user. So we wanted to do something about that, and we wanted a solution that was kind of an all-in-one, right? And so we built it. We didn't intend to become a camera company by any means, but the market demanded it, one, because of price point, and two, because of reliability. We were using a lot of off-the-shelf cameras, and frankly, they wouldn't last very long. We would have to replace them all the time. And there is a question actually in the Q&A, and I want to answer that here with what is the maintenance and support frequency and effort to keep those running under various weather, wear, tear, and conditions. So this is purpose built for Autonomous 365, and it's purpose built for oil and gas. Very industrial environments. We have a gimbal built in to keep things stable in high wind situations. It's all IP66 rated. It's built for rugged environments. It has all your compute built in, has all your communications built into it, and it's modular. So as use cases change throughout a life cycle of a well or a central tank battery, you can pull that, you can modularize that camera to fit the budget of the well, right? Every well is its own individual company. And so we can scale up and down. There's two different types of cameras, right? There's a full OGI VOC camera, which is what you guys are used to more than likely. If you're Eldar folks, is it's $100,000 camera, right? And so, for facilities that makes sense on some facilities, and a lot of facilities it doesn't make any sense at all, right? So there's a methane only camera, right, that is going to see 90% of what you needed to do from a methane standpoint, and that's a long wave thermal camera. You have a mean time to failure 7 to 10 or 5 to 7 years, could be up to 10 years. So it's variable, right? It's variable on the conditions of where the facility is, but it's also built into the program, right? So maintenance is built in, on a cooled core OGI camera. Those are as a service, right? And your warranties are built in. All of that is built in and baked into kind of the whole program. So Minerva's very exciting, and yeah, it can run the Autonomous 365 package. And there's a Halo version of it, which is the smaller version, right? So on facilities that don't need a full Minerva system, you only need a methane only camera, and you need to do just some light security, then there you go. You can run a Halo system at less than quite a bit less in terms of upfront cost.
So, what our clients are saying, but they like it, the speed, it's faster than the super emitter satellites. People, reduces windshield time because they're doing way more remote monitoring and management. Safety, if you can send less people out to the field and keep them out of harm's way, it's safer. Again, remote monitoring and management. Managed by exception. Everybody wants this, right? The clients want this so that, they're only getting alerted when there's something actionable to do. And then, the ROI is, our clients are telling us the system pays for itself by eliminating essentially one call out a month at this point. So again, we're trying to get to this point where you're going from manual LDAR to autonomous LDAR, manual AVO to autonomous AVO, manual method 22 to autonomous flare monitoring, manual flare management to autonomous combustion efficiency, manual tank monitoring to autonomous tank monitoring, tanks overpressuring to prevent that from happening, prevent cold venting, having essentially agents out in the field are 24/7, safer remote autonomous operators, painful emission compliance to automated future-proof compliance, and eliminating the super emitter notice and fines by just eliminating the super emitters if you can. I can go into a lot of detail about this, but what engineers need to design into new sites is continuous monitoring, and that way regulations, they're all moving toward continuous. It really is pushing in that direction, and EPA is enforcing super emitter. So our system allows you, by building that in, it allows you to monitor for all these things. In addition, stuff we didn't show you, like liquid leak, fire, smoke, PPE detection, security, and much more. ProMax, with data exchange, again, allows you to take that model that you use for a permit and then set it aside. Now it becomes real time. It's used, right in production. And first principles, auditable records, subpart W approved. And if you get CleanConnect, we actually include this ProMax data exchange. Okay, so you don't have to do a separate thing. We actually implement that for you. Smart emission control devices like Cimarron, DreMax, and ArcFlex. It allows for the remote monitoring and management, allows for direct measurement, allows for, it meets these new regs. And again, more and more direct measurement. We see more and more manufacturers allowing us to tap into the direct measurement. Obviously, as you're designing brand new sites, high pressure storage tanks, and then redundant smart VRUs, smart flare controllers, and certified combustors and stuff. And I give you a bunch of examples of companies that we work with and certify that they work with our system. So anyway, I know I wanted to rush through that last part because I know there were some questions in there. So how does quantification compare to CleanConnect's current quantification via OGI? How does this quantification? Oh, okay. So do you mean like, Caitlin, I wonder if she means how does ProMax's quantification? Anyway, you want to tackle that one?
Yeah, I mean, the combination is really powerful, right? Both scenarios are going to be, better in certain scenarios, right? But whenever you have a redundancy there and you say, okay, I'm pulling two measurements, actually. Every leak I'm pulling a CleanConnect measurement, I'm pulling a ProMax measurement. And then how do you reconcile those, right? That's the question. So I would, first principles is probably, the best way to do that. Default ProMax calc, and then matching duration and adding the duration into that is what's going to be really, really powerful. That's how I approach it. At least that's my philosophy on it.
Yeah, and I can add one more thing to that. With the with CleanConnect's ability to do this continuous LDAR, and then using ProMax to supplement it, they're really the first to the market on this. And what's so exciting about it to me is that with the ProMax model, you know what your composition is everywhere, always in your system. And then what this continuous LDAR is able to do is say, oh, you're having some emissions right here, right now. And it could be a very brief period of time, and it could be a long period of time. If it's a long period of time, then ProMax will probably catch that too. But if it's a very brief period of time, unless you have ProMax running every 2 minutes, then what I would do is I'd use the composition that you have in ProMax plus the continuous monitoring that the LDAR gives you, and that's going to give you a pretty solid result.
And we also use it for the OGMP level 4 and 5. So level 4, source level, we see that. We see the emission event. We measure that. And then we're doing in the same exact time sequence, we're measuring the mass balance loss. So a site level. So now you have level 5 reconciling with level 4. Kind of answers that. Oh, yeah, another question. How can I use results from a short duration, 1 to 2 hour OGI measurement to determine routine venting for VRU sizing? Most of the time, vent measurements are not the same when you measure at different times. Either you want to tackle that one?
Yeah, I'm not sure I understand the full picture there on that.
I guess
go ahead.
I would hope that the VRU would be sized before that happened. But I'd probably size the VRU off of your design model, and then run some scenarios of what your highest scenario of venting could possibly be from that particular vessel, and then size it based on that. That's how I would do it from the modeling perspective. The LDAR, I think, would be more of an after it's been built sort of. I would expect, right? Am I wrong?
Yeah, no, I'm tracking with you. Yeah.
And we can, we'll have some future webinars with Cimarron that can tell you everything you ever wanted to know about VRU sizing.
Yeah, it's true. Yes.
Literally, I'm one email away from VRU sizing kings. All right. Amantha asks, thanks. How much of the recorded data from the camera is made available to the customer? So talking about the logs and stuff, and do you get PPM type reading along with a plume image? David,
you're going to get a flow rate, so scuffs per hour, and then that can be converted to a PPM reading. And the raw data from the camera is available, so it's exception, right? So it's exception data with live view capability, so you can tap in and kind of inspect your facility on your own without the AI if you would like. But every leak is going to be logged in your log, and that's kept for as long as you need it typically, by the regular, if you're in Colorado, I'm not sure where you're at, but regulatory wise, it's 5 years here in Colorado. So that's kept in cold storage, and you can bring that data back down.
Heather asks how these Minerva sensors are powered. Is it wired, solar, battery? What's the data recording and transmission frequency?
Yep. So 120 VAC line power. We do have a solar deployment going on as well with the Halo system. And what was you hold on, let me go back to answered because I missed the last part of that. The frequency, I think, was it?
Yeah. So how, it's
what's the data recording transmission frequency? Yeah. So the transmission frequency is as often as you emit, or as often as there is an event. So again, it's an AI watching the camera. It's a computer watching the camera 24/7, and then letting you know what you need to worry about as a human. So the transmission happens as long as there's things happening at the facility that you want to look at or that you want to know about. And then the data recording is relatively straightforward. You're getting a video clip or an image from your facility. It's an alert, allows you to log it, put it into your work order system, and get things fixed. That's ultimately how that works.
All right, Matthew asks, can you view real-time ProMax data in a similar way to a traditional model flow sheet Visio interface? Justin, I'll let you take that.
Yeah, and so the answer to that is yes. It's there are two different ways to do it. You can actually use the real ProMax flow sheet if you wanted to, and you can monitor your facility just from the flow sheet. You can have it automatically execute. It'd be just like you're there clicking the button, say execute. You can do that. You can have it automatically do that for you. Every so often, every 2 minutes, 5 minutes, 10 minutes, hour, whatever you want, and it will show you whatever the most recent data is, as you have it configured. There's also another way to do it. Mark, do you mind if I share my screen?
Yeah, but before we do,
Okay.
I'm going to just tell people, because I
Okay.
know we're run up against the hour here. If you go to info.cleanconnect.ai/EPA, okay, you're going to get a number of things up there on this sheet. Number one, access to my EPA cheat sheet. Number two, this webinar replay will be up there, but everybody who registered here will get that. We have a new program called EnergyPT. We're in alpha stage in the development, but that basically allows you to type in questions about any kind of regulation and get an actual answer. Because people always ask me, hey, Mark, how do you stay up on like 2,800 pages of regulations? Well, we, CleanConnect is an AI company, so we're developing our own AI solution for that. And you get access to that if you want to join the alpha program. And also ProMax has made available some training videos about some of the features. If you want to know more of the details about the features that you saw here today, you can get all of that at info.cleanconnect.ai/EPA. Okay, so share your screen.
I will show my screen here. So Matthew, this answers your question in slightly another way. Hopefully y'all can see my screen now.
Yep.
But this here is actually showing a well site facility in real time. So this is telling me right now that my current RVP at this facility is 7.4 psi. All these red values in there are showing me my instruments that I have. So all my temperature and flow rates are coming in through meters or instruments there. And then all those blue values you see calculated, like my emissions and my RVP, those are being calculated. I think I have this model running every 2 minutes right now, but it's just always running. I've had this one running for over a year now, and it's always giving me the information I need. So that's another way that you can do it. So the nice thing is once you have all this data in a database, you can visualize it any way you want. And there are a lot of really great tools out there that can visualize it for you. Like this right here is actually a third-party software called Pi Process Book, which is what I'm using. But I think this would be a really good way to look at your data as well.
All right. Well, we're 4 minutes past the hour, and I want to thank everybody for being here. And like I said, I did put into the chat the info.cleanconnect.ai/EPA. You can get access to all that follow-up material. We will be sending out a replay shortly to this in case you had to drop off early or you want to share it with your colleagues. And listen, we appreciate everybody for being here and super excited to be working with ProMax, BR&E, solving a really complicated problem. But honestly, I can't even imagine how we would solve it without it. So we're so grateful for this piece of software that you've labored to create because it really helped us and get the job done for our clients, for our mutual clients.
Excellent. Yeah, no, I'm excited about it too. This is a really, really amazing product that y'all have created too. So I'm really excited to see it in use more and more everywhere I go. So this will be good to see.
Wonderful.
All right. Thanks, everybody. Again, you can, I'll be sending out a replay. If you have individual questions about how this might work for your specific environment, you can always respond to my replay message and say, hey, Mark, I'd really like to spend some more time with any of us here to get specific questions answered, we'd be happy to do it. Anybody who uses our stuff, we're pretty dang excited about. So with that, I'm going to say goodbye. Any last thing, David and Justin?
No, just thank you, everybody. Appreciate it.
Yep.
Thank you.
All right. Bye-bye.
All right. See y'all later.